Okay? The key to these problems here is you have to read it to see what the directions are in order to determine whether you're putting a minus sign in front of the P dot. Well, P is always a positive value, but the P dot, the P double dot, the omega, and the alpha. You need to read that in the problem statement. So, if you look at this here, it says a block slides on a rod moving away from the center. Anything away from the center, this implies that P dot, being the velocity, is a positive value. When it's towards the center, it's a negative value. But in this case here, we are in the problem statement that says that P dot is moving away from the center. Therefore, it's a plus P dot. Okay? And that means that this is plus 20 centimeters per second. While speeding up. So anything accelerating means that it has the same sign sense as the velocity. Therefore, P double dot equals a plus 30. Now, if I said it was slowing down, the sign sense is opposite of what the velocity sense is. So if velocity was going towards the center, being negative, and I was saying that it was slowing down, the P double dot value would be positive because it's going away from the center.
So always find P dot versus the no line of that.
Right. Gives you the sense of what P double dot sign will be. All right. Then we continue, so the rod is rotating at an angular velocity of 10 radians per second in the direction shown. So I'm showing that omega is equal to a positive 10. While increasing in speed, so that means that your alpha value is in the same direction, so your alpha value here is equal to plus 15. Okay? Does everyone follow that? Because I will state the problem in a very similar fashion on the exam otherwise.
What are, sorry, I know you've gone over this, but the three problems, is this the graphical one?
It's not graphical. We don't do any graphical.
Oh, it's, what is it, because I know that the one that we use Excel is the analytical one.
This is the total acceleration of a block using the analytical approach.
So this one is analytical, but this isn't.
This is
So there are three problems. What are the three types?
The three problems are total acceleration, which is this problem that I'm doing now. Analytical acceleration analysis on a 4-bar. And then analytical acceleration analysis on a crank swing.
Thank you.
Let's continue on this. Go ahead and fill out these values. So you got plus 20, plus 30. Oh, sorry.
That's fine.
So on this right here, because I do not give you the p-value,
You have to measure.
you physically have to measure it. And when you measure this thing here, you see that it is 4. Right? So you measure it from the origin up to the little dot in the middle. So P is equal to 4. So this is 4. P dot is 20. P double dot is 30. Theta, you have to measure theta here too. and when you measure theta, notice that theta equals 160 degrees right here. Omega is 10, alpha is 15. All right? So from that, you go ahead and perform the analysis. So for the velocity of the ball, that equals P omega j e to the j theta plus P dot e to the j theta. Or another way of writing this would be P dot plus j P omega times cosine theta plus j sine theta. Everybody see where I get that? Which equals 20 plus j 4 times omega 10 times cosine 160 plus j sine 160. All right. Let's see.
That's right.
So what I do on this equals 20 plus j 40 cosine 160 degrees plus j sine 160 degrees. Let's see, do I work this out? Let's see, I know when I don't have it worked out explicitly here, but I know when I do this, I get minus 32.475 minus j 30.747. So when I do the math on this, which is, so I want to, I could write this out so that it's 20 cosine 160 minus 40 sine 160 plus j 40 cosine 160 plus j 20 sine 160. And when I do that right there, I get, if I add these two numbers together, I get minus 32.475. When I add these two numbers together, I get minus j 37.47. Right? From here, the magnitude of this here is equal to I do that squared plus that squared, square root of that, I get 44.721. And the angle is equal to inverse tangent of minus 30.747 divided by minus 32.475. I see that this value right here is negative, so I go plus 180 degrees. And I get 223.435 degrees, which is the same thing as minus 136.565. So your answer for the velocity, this is the velocity equals 44.721 e to the j minus 136.565 centimeters per second.
But you would also accept the 223?
I would, because it's the same angle. So this right here, this is 44.721, and the angle is minus 136.565.
Why do you prefer the negative one?
Why do I prefer it? Because it's less than 180. The absolute value is less than 180. So what is the answer? Is that the answer?
That's correct.
Yep. Okay. So that's the velocity part. So I need to do the acceleration part now. All right. So the acceleration part